Hello, hello. So in this video, we're looking at how to solve equations that involve a modulus function. So if we look at this question here, it says solve the modulus of 2x minus 7 equals 5 minus x. So basically, we've kind of got two functions here. We have the modulus of 2x minus 7, and we have 5 minus x. And the idea of questions like this is we can plot them both on a graph so that we can see the points of intersection. And those points of intersection will be the solutions. But then we have to solve them algebraically to actually find out the exact x and y coordinates. So if we give that a go, let's plot this one here first, 2x minus 7. So the key with these ones is just to plot the normal one first. So don't worry about the modulus sign at first, let's just plot 2x minus 7. So that's going to have a gradient of 2, and it's going to cross the y-axis at minus 7. So we know it's going to cross down here at negative 7. And then it's going to cross the x-axis at 3.5. Yeah, you could do 2x minus 7 equals 0, and then rearrange that and we'd find that it would cross the x-axis at 3.5. So if we draw that as a line, it would look something like that. Yeah. But then we have to take into account the modulus sign. And remember, the modulus means that the values can't be negative, or the output can't be negative. So it wouldn't go below the x-axis here. This bit here would actually be reflected over the x-axis above. So it will come across at 7, and it will basically come up like this. So this will be our graph instead. Yeah, we ignore this bit down here. Then what we need to do is draw this one here. So 5 minus x, so it's going to cross the y-axis up at y equals 5. So say that was around here. And across the x-axis at x equals 5. So we'll say around here. And that means that'll basically come through like that. Obviously, in the exam, you'd want to use a ruler for these things. So hopefully, if you look at that, you can hopefully see that there's a couple of solutions there. We have this solution here from this intersection point, and we have this one here from this intersection point. So now what we need to do is solve to find each of these. And for that, we basically have to take the positive and the negative version of our modulus. So the way I think about it is, if you look at this part here of the line, so this bit of the purple line here, this hasn't been affected by the modulus. Yeah, we didn't put this here because of the modulus function. So to find this solution here, it's when the normal positive part of our 2x minus 7 intersects our 5 minus x. So to find that solution, we do 2x minus 7 equals 5 minus x. Then we can rearrange, add x to both sides to get 3x, add 7 to both sides to get 12, then we get x equals 4. Yeah. So that there is x equals 4, which looks about right because we know it's between 3.5 and 4. And then we can plug that value of 4 into either of these. So if we plug it into the y equals 5 minus x equation, that would be 5 minus 4, which equals 1. So this coordinate here is 4, 1, because that's our x and our y. To find this solution here, though, if you look at this bit of the purple line, this bit of the line has kind of been modulus, if it makes sense, because this was the original bit of the line. But because of the modulus function, we flipped it up. So to find this solution here, what we have to do is actually take the negative of 2x minus 7 and set that equal to 5 minus x. Yeah. So if the part of the curve that makes the intersection point has been modulus, has been affected by the modulus sign, you take the negative of that modulus function. So if we expand this, that's going to be minus 2x plus 7 equals 5 minus x. Then I'm going to add 2x both sides so that I get an x on the right, and take away 5 from both sides so that I get 2. So 2 equals x. And again, that makes sense. This is 3.5, so this is around about 2. And then we can plug that in. So if y equals 5 minus x, then y will equal 5 minus 2, which is 3. we get 2 and 3. So this point here is 2, 3. And that's it. We found the solutions. So x equals 2 and y equals 3, or x equals 4 and y equals 1. Those are the two solutions to this equation. So hope that all makes sense. It is a tiny bit weird to get used to the whole, like, when you take the negative of the modulus and when you leave it in the positive version. But hopefully that makes sense. If you have any questions, then let us know and we'll answer those as soon as we can. And otherwise, I'll see you in the next video. Thanks.